Fine. So I hope you are able to hear me and see the screen, right?
Yes, sir.
Okay, thank you. So we were discussing about the three important definition. We talked a little bit about discrimination last day, and we introduced ourselves to at least three different forms of discrimination, starting from disparate treatment, then disparate impact, and then finally disparate mistreatment. So today we are going to talk a little bit about some very well-known notions of biases. Many of them, as you will see, will time and again reappear in different uh, settings of experiments, like which probably will be doing in your term projects, or later on if you are interested in this kind of research, or even in various industry problems. Okay, so the first one that we will talk about is called historical bias. Now, what does historical bias mean? So, as the name suggests, there is something that connects to the history. Basically, uh, it pops up due to certain socio-technical issues that are already present uh, across the world, or is it, or should we say that it is widespread across the world? So due to these socio-technical biases that are already present globally, the data set that is curated automatically actually manifests, or the bias automatically manifests in the dataset that is curated from this world population. Okay, so that kind of a bias is called a historical bias. So basically, we can write the following, like, very succinct and short definition as this. So this is a bias that already exists Okay, so this seeps into the data curation process because of an already existing socio-technical um, like disparity uh, across the world. Okay, and this can happen even when you are doing a like a perfect sampling, a very correct sampling. Okay, even then this can happen because this is already prevalent worldwide. Now, there was this very interesting example of the historical bias where they had a search test on the Google image search in 2018. Okay, and where the search query was about women CEOs. And this resulted in a very few number of female CEO images. Okay. So if you ask, so in 2018, the query that was ran was like top women CEOs, okay, on the Google image search. This resulted in very few images of women CEOs. Okay. So now the reason behind this is the following, that in the Forbes list of top, say, 500 CEOs, at that time in 2018, only 5% were females. Okay, so you see, like no matter whatever way you do the sampling, since the uh, like the uh, basis of the data or the basis of the population from where you are sampling the data itself has this like strong disparity, like say taking the top 500, or even say if you take 1,000 CEOs, you won't get more than 8% females. Okay, so therefore it is very difficult to find out images of top women CEOs in the Google image search, because it's not there. It does not even exist. Okay, so that's why there is this disparity, and this is termed as historical bias. The next form that we will, yes, any
Um,
questions?
was it? Yes. Was it that only a few images were only a few images were shown, or was it that out of all the images, only a few of them were women, the other were say men or something?
No, so see, when this kind of like experiments are done, typically you would restrict yourself to the first 2 pages or first 3 pages, right? You can, of course, go down to the end of all pages. By that time, like you will be probably able to retrieve off all the 5% females. But like typically, your interest would like die down. Think about you searching something, right? Your interest would die down after the, say, possibly the second or third page. For many it is like yeah, in fact for the 50% of the users, it would be I would imagine within the first 2 pages. Okay, so that was the case. So after the third page, people rarely go deeper down. So within that, like there were very few examples. Does that answer your question?
No, sir. What I was asking is,
Mhm.
did the results have only women? Even the first two pages, did they have only women, or did they
No,
have
that is
men?
the interesting thing. Like they will also have a lot of male photos in
Okay,
them. Okay.
got it.
So that is, so it was not getting enough results in the top list. So the algorithm was confused because the data itself is historically so biased. Make sense?
Yes, so it was picking top CEOs when it was
Yes.
not finding top women
Yes.
CEOs.
So now if you say like they did not do it perhaps, but if you say top women CEOs, okay, if you put it under quote unquote and force it to actually find out women, then there will be very, very few results. Okay. Then the next form was representation biased. Thank you that you asked these questions. These bias definitions are very nuanced. Try to follow them carefully. And I think like this, it is a good idea to prepare a table lookup for these bias definitions, because you will come time and again you will come across these. representation bias. Okay, so here, as the name suggests, this happens when, like, depending on how we define and sample from a population. Okay, so the idea is that this takes place based on the way we define and sample from a population. Okay, so maybe one form of representation bias could be lack of geographical diversity. Okay, so uh, how many of you have heard about this data set? This is a large repository of images. And it is used as a benchmark data set for many different image processing algorithms. Okay, so like every now and then, this is being used, this data set is being used for like testing various like developments in the image processing literature. Okay, however, this is known to be strongly biased towards, any guesses? Biased toward a specific geography. I guess now you can guess. This is the Western world. So we, in our one of our earlier case studies, also came up with representation bias. Recall? Do you recall? This kind of geographical diversity was also in the lacking in one of the case studies that we did. Which one? Hmm?
In Compass?
No? What about gender shades? The two benchmark data sets that the authors were showing and then they discarded them. What about those two data sets? The IJBA and ADNs? Wasn't there not a representation bias? It was highly light color, light skin dominated. Recall? That's why the authors discarded these two data sets. Make sense? The next form is the population bias. Now, the population bias arises like whenever the statistics, the demographics, the representatives, as well as the user characteristics are different in the user population and the data set from which, and the data set which is built from that user population. Okay, so population bias is seen to arise when statistics, demographics, representatives, and user characteristics, among many other things, are different in the user population represented by the data set from the original target population. So there is a data set, okay? There is a data set which has a particular population represented, but this is different from the original target population on the basis of statistics, demographics, representatives, as well as user characteristics. Okay, some of the interesting cases of population bias arises when you look into certain social media platforms. Okay, so now if you consider on one side so let us consider these two pairs of social media platforms. Okay, which platform do you think men are more active? Any idea? Okay, this is coming from real data analysis. Any idea?
Reddit.
Reddit. Okay, so
Reddit.
here, so it is observed that men are more active on platforms like Reddit and Twitter. Okay. Similarly, women are more active in platforms like Facebook and Pinterest. So now this actually causes a difference in the like the two population. Now if your original target population is from here, okay, and you want to make conclusions on the population from Reddit and Twitter, and you want to do it based on the population of Pinterest and Facebook, then this is going to be wrong. Okay, so this is where the population bias creeps in. Suppose you want to make some inferences about, let me call this M dominated, male dominated, and let me call this female dominated. Okay, if you want to make some inferences about the male dominated population, so this is your target population, using the female dominated population. So this is your data set. Okay, then this might result into biases. Okay, so this is about the population bias. The next form of bias is very interesting. This is called Simpsons Paradox. Now, what does this tell? This tells that whenever you see a data set at the aggregate level, then certain things that are not apparent to you can become apparent when you segregate the data and like look at the finer subdivisions of the data set. So the subdivisions of the data set reveals certain facts which are absent, or which gets lost when you aggregate the data set. Okay, so suppose you have some finer subdivisions of the data set. Are you telling something? Is someone telling something? Okay, so finer subdivisions give a different story or tell a different story from what is observed at the aggregate level. So at the aggregate level, sometimes some things might look biased. Okay. However, when you look into the finer subdivisions, you get a reasoning which tells you that probably what is observed at the aggregate level is not correct, or is not actually a resultant of some sort of a bias. Okay, so the formal definition is as follows. A trend or characteristic observed in the underlying subgroups, subdivisions may be different from the trend characteristic observed at the aggregate level. Okay. So one of the very interesting cases of this Simpsons paradox happened when there was a lawsuit that was filed against the UC Berkeley admissions team, complaining of a gender bias. Okay, so there was a set of people, actually a set of students who felt that there was some sort of a discrimination based on gender that was going on in the UC Berkeley admissions procedure. Now, the observation was that there was a little bias toward women, and a smaller fraction of them were being admitted to the graduate programs, okay, compared to the male counterparts. So there was this complaint that women students were given lesser admission into the graduate programs compared to the male candidates. Okay, so now the admissions committee went back and tried to analyze their data. Now, what they did was they broke the data into departments. So these are the subgroups or subdivisions that I was talking about. Okay, so they broke the data into various departments, and now for each of these department, they analyzed the admission differences, okay, between the women applicants and the men applicants. And what they found, to their surprise, that the that in most of these cases there was no discrimination. So department wise, there was no discrimination, and in some cases, women had a slightly larger fraction of entry. So then the question is, where is the fallacy or the paradox? Right? So they went and dissected the um, whole data set, broke it into departments, and for each department studied the fraction of admissions for women compared to the fraction of admission for men, and they found that it was there was absolutely no discrimination, and in some cases women admission was a little higher than the men. So then what went wrong? Why did they see that signal at the aggregate level that women were discriminated? Any any thoughts? Any idea how this could have happened?
So might be the number of students in each department were a lot different from each other. So
Uh,
individual,
no,
even
that is okay, but like the admissions were being granted in a non-discriminative fashion. Does it really depend on the number of students? Exactly, on the number of students. Maybe you are coming close. Think a little harder.
Like in the departments where there were slightly more males had a much larger size compared to departments where there were slightly more women, those were smaller maybe
But
over.
they are comparing fractions.
Yeah, so like at the aggregate level, the number of males will increase if departments that have slightly more males have overall higher number of students.
uh, slightly larger number of males.
So like it's
No,
52%.
that was not happening. As you see, like they were telling that in almost all departments, like uh, there were uh, like females and males were like very close, and in fact, in some cases, females were more. Think a little bit hard. You are coming very close. It has to do with uh, something related to, I mean, not exactly the number. Let me give you a hint. Let me give you a lead. Then try to think. Suppose there are two departments, X and Y. Here, historically, it is known that the admission rate is low. Tough to get in. And here, it is known that the admission rate is moderate to high, not very tough to get in. Now, in the light of this information, can you think what could have happened? And there were
Maybe
some set of departments like X, and there were some set of departments like Y. Yes, you were telling something.
maybe women applied to more competitive departments.
Exactly, that is what had happened. So more women were applying to these competitive departments. Okay, while more men were applying to these less competitive departments. That's why, like at the aggregate level, there was an there was a bias that was observed. Okay. However, when they digged deeper, they did not really see this bias featuring anymore. So the next form of bias is what is called sampling bias. And as the name suggests, this arises because of non-random sampling of data from different subgroups. Okay. So now a bad consequence of this is that your model's trend on one data set will not generalize on another data set because, or here data set means one subgroup. I mean dominant in one subgroup. Maybe this is non-dominant in any subgroup. I mean equally represented. So if such a test data comes in, then your model that is trained on a data set which is dominant in one subgroup will like utterly fail. Okay. So the next form of bias is called interaction bias. Now, as the name suggests, this arises due to some form of interaction of the user with the computer interface. Now, there are again under this two types of interaction biases. One is called the presentation bias, and the other is called ranking bias. Now, what is presentation bias? Presentation bias appears because of the way results are shown on the UI. Can you think of a small example of this kind of a bias? It is based on how the results are presented on the screen. Suppose you are using a user interface and the results are presented in a certain way on the screen. And this way of presentation might lead to a bias.
So any
Like,
IR system,
Okay, go a little deeper.
search
The
engines.
IR is what kind of, I mean, what is the quantification of the bias that you're thinking about? You're very correct.
So
Think a little.
let's say I'm searching a particular query and I'm getting queries relevant to a particular subgroup only in the first 10
Mhm.
results. So
Mhm.
they are in the next 10 results I'm getting to a particular other subgroup, which is the bias toward that subgroup.
Okay, and can you think a little bit as to how will this bias get over time pronounced? Why do you think that this bias will creep in to an inadvertent consequence?
Because a particular subgroup may get a certain amount of facilities based on those responses initially.
Uh, Facilities
Let's say
is.
I want to donate to a particular subgroup, let's say, and I'm
Hmm,
getting only first 10 results. Okay, these people
hmm,
need money. So
hmm,
only donate to that subgroup and not going to donate to the other subgroup because I don't
hmm.
know about them. So sort of like
Okay,
news gathering or something like that.
very good. That is one. Like uh, a little bit more, maybe a little bit more. So your example is perfectly correct. So, but a little bit more like downstream. Maybe what you are trying to mean is the following: that some items are getting higher, what we call in IR terms, click advantage, right? So this is very apparent, like especially these days, I guess all of you have used e-commerce platforms, and like this is one of my particular area of research. So that's why I'm picking up this example, but you can think of other examples also. Think of like shopping on Amazon or Flipkart. Okay, you have items here. Now, suppose given a search query queue, always a particular set of items are retrieved and shown. So what will happen? These items will be clicked more and more. Okay, and you will land to their product pages. Now this will increase the click-through rates of this set of products only, and therefore this will again get pumped into the system, and it will further like heighten the position of these products in the list. Okay, so you see it's a vicious cycle that's going on. Like these products are presented usually roughly at the top, so therefore the users have higher probability of clicking them, while the users are not seeing most of the other products, like the example that he was giving. So similarly, one group of products or one subgroup of product is being shown to the users. This subgroup of product actually is clicked more and more by the users, and therefore it is getting recommended also uh, for like different, like in the recommendation list of other products, because of this increase or enhanced click-through rates. Okay, so this is a cycle that keeps on, and therefore this kind of biases could be very, very severe, could have very, very severe effects. The other one, ranking bias, is very close to this. So where is exactly what he was suggesting. So the top ranked idea, the top ranked results are the most relevant results and will attract the highest user attention in terms of click-through rates. Okay, so this definition has a ranking involved in it. This definition precisely does not talk about the ranking, it talks about the ergonomics or the way things are presented on the screen. Okay, and if you are showing certain things only on the screen, so those things will have a higher chance of getting clicked by the user, and that in turn will make those things more and more popular, while hiding the other things completely. So for instance, think of like again the e-commerce platform, where certain sellers or products from certain sellers are only being shown in the first one or two pages of the search results. Okay, so and one can imagine that these would be like the dominant sellers. So those sellers are already getting a high number of click-through rates, and therefore are like highly probable of being recommended with any other products of similar category. Okay, however, this effect actually has strong ramifications to the business of the very small scale sellers. And these days there are many small scale sellers who have registered onto these platforms, and they are paying money to showcase their products in these platforms, especially in the pandemic times. So therefore, this kind of a presentation bias in such e-commerce like platforms could be extremely detrimental to such small scale industries, and it might completely ruin their business. So the next form of bias is called the emergent bias. So as the name suggests, emergent bias means the bias emerges. Okay. So basically what happens is when you design, so this is also an UI based bias. Okay. So when you design a UI or an application, you have an idea of the requirements of the user, okay, who are going to use this application or the UI. You just make some hypothetical belief structure of what the users might be wanting. So, and based on that, you develop this UI or this application. But now over time, what one observes is that the requirements of the user, the needs of the user actually changes, or it might be that the UI or the application actually crosses its boundary and comes to some other um demography for which it is not suited, okay, in the first place. And this kind of, and if this kind of situation arises where an UI or an application starts getting used by a different culture or by a different by a set of people who have a different socio-economic or socio-cultural background, then that could result in what is called the emergent bias. So that's emergent bias. Okay. There are like two more. I'll not bore you further. Like with these two, we will finish off this bias part. Okay. The next one is the self-selection bias. This is very similar to the sampling bias. But here, there is one specific difference, that is the subjects take the liberty of choosing themselves, like while doing a survey. Okay. The the so if say you are doing a survey, you take the liberty of including yourself in the survey. Okay. That is where the self selection bias creeps in. And as you can understand, this will definitely have inadvertent consequences. Okay, because their inputs might be automatically strongly biased. Okay, because they know like what is the survey being done for, what are the background requirements, or what are the background objectives for which the survey is being done, and this knowledge will like creep into the survey inputs that they are giving, and this might cause a bias in the results that you observe. So this is the self-selection bias. And a very like mm, similar type of bias connected with the self-selection bias is what is called the observer bias. So what happens here? So where researchers actually, typically subconsciously, I would not say like they do it on purpose, subconsciously project their expectations onto their research outcomes. Of course, there are some news every other day where the this projection of expectation was not really subconscious or unintentional, but it was intentional, and that's why researchers fudge their data in such a way so that it matched their predictions. And you get to see so many scientific papers being retracted when it is found later on that the results that were presented in the paper were unfounded and could not be reproduced. So these kind of situations arise like when there is a observer bias. So one example of observer bias could be like, say, if you start influencing users who participate in a survey required to substantiate the outcomes of your prediction. Okay, so if you start going to them and modifying and start trying to modify like their views in order to like twist their inputs so that it matches your prediction. So if these kind of things happen, then this would result in observer bias. Okay, so we'll stop here, and next day we'll start with fairness constraints. Any questions?
Sir, is there any test at 22 January?
No, we will have the test on 29th. I'll tell you tomorrow or day after tomorrow, I'll tell you the date. So the test will be on 29th Jan. Okay, we will stop here.
Sir, just one request. Can you share these handwritten notes with us?
Okay, I'll share the hand. Actually, there was some students in the earlier batch who said that, sir, please give the typed notes because it is sometimes not possible to read out your hand notes. So I was giving the typed notes. If you also want the handwritten notes, that can also be shared.
I mean, sir, anything like these notes basically. Like
No,
not.
these notes, I have already shared the typed notes for disparate treatment, etc.
Okay, sir, can you
On the
please?
Teams,
Okay, okay.
on Teams, as well as on my course website.
Okay, sir.
If
Thank
you
you.
go to my course website, it's there. It has been all shared, also on the Teams posts.
Okay, sir. Thank you so much.